Hello. So in this lecture, I'm going to discuss about three important things of T flip-flop. And the things are truth table, characteristic equation, and excitation table. Okay. So first of all, let me give some brief idea of T flip-flop. Actually, in T flip-flop, you have one input that is known as T, and as it is a flip-flop, you need to give clock signal, and it will have two output. One is Qn, the other one is Qn bar. Now, using the input and the present output. So present output is denoted by Qn. Okay. You have to find out what will be the next output. And the next output is denoted by Qn plus 1. Okay. So this is the main objective of truth table. So in the truth table, input will be there, the present output will be there, and using these two things, after applying the clock, what should be the next output that we need to determine. Okay. So in truth table, what are the things are there? You have input T and you have present output, that is Qn. And using these two things, you need to find out the next output Qn plus 1. So what does it mean? After applying the clock, what output you are getting, that is denoted by Qn plus 1, that is known as next state output. Okay. Now, by default, you have some clock signal you need to apply. Now, as you have two input variables, how many combinations will be there? Four combinations: 0, 0, 0, 1, 1, 0, 1, 1. Okay. Now, if input is given 0, suppose you can divide this table into two parts. So if the input is 0, it means if you apply t equal to 0 in these two cases. In these two cases here as well as here, you can see t equal to 0. Okay. If you t equal to 0, then whatever may be your present output, the next output will be the same thing of the present output. Okay. So what does it mean? If you have the present output of Qn that is equal to 0, after applying the clock, same output only you will be getting in this Qn, and that is generated by Qn plus 1. Okay. Similarly, if you have the output of 1, then after applying the clock, still you will have the output of 1. And this particular thing is known as no change state. Means in T flip-flop, if you apply t equal to 0, this particular state is known as no change state. Why? Because if your present output is 0, next output will also remain same. If your present output is 1, after applying the clock, still the next output will be 1. Okay, there will be no change of the output after applying the clock. So that's why this is known as no change state. Now come to the next case when t equal to 1. So you see here t equal to 1, in this case also t equal to 1. Okay. And in t equal to 1, this particular thing is known as toggle state. What is toggle state? Toggle state is in the T flip-flop, if you apply t equal to 1, whatever present output you are having, after applying the clock, you will get the inverted version of the output. So what does it mean? If your present output is 0, you will get the output of 1 after applying the clock. If you have the present output of 1, after applying the clock, we'll have the output of 0. And this is known as toggle state. Okay. So briefly, what you can tell from this truth table, in T flip-flop, if you apply 0, then there will be no change. No change means if your present output is 0, after applying the clock, still the output will remain 0. If your present output is 1, after applying the clock, your output will remain 1. So this particular thing is known as no change when you are applying t equal to 0. Now for the other input case, means when t equal to 1, in that case, this is known as toggle state. Why it is toggle? Why it is called as toggle? Present output you are having, the next output will be what is next output? It means after applying the clock, what output you are getting, that will be the inverted version of the present output. It means if your present output is 0, the next output will be 1. If your present output is 1, the next output will be 0. So this is the truth table of T flip-flop, and using this truth table, you can easily find out the characteristic equation. So as in the truth table, two input variables are there. You can write down T and Qn, and from there we need to find out Qn plus 1. So use this KMF, and from the KMF find out the characteristic equation. Okay, so put the value 0, then 1, then you have 1, then 0. Okay, so what will be the expression? Qn plus 1 is nothing but T Qn bar plus T bar Qn. Okay. Now, what will be the excitation table? Now, if you have followed my previous lectures of SR and JK flip-flop, you can easily understand that excitation table easily can be implemented from truth table. Now, what is excitation table? Excitation table. What is excitation table? In excitation table, you will be given present output and the next output. And from these two things, you need to determine the value of input. Okay, this is known as excitation table. So what other things are available? Qn and Qn plus 1 are available to you, and you need to determine the value of T. Okay, now how to do? So you make, as you have two things given, means Qn and Qn plus 1 are given to you. So you make 4 combination 0, 0, 0, 1. 1, 0, 1, 1 using two variables, 4 combination you can make, and now you need to determine the value of T. Now, how to determine the value of T? You need to take the help of the truth table. How? This 0, 0 combination you see, where is the 0, 0 combination in the truth table? This is the 0, 0 combination. You have Qn equal to 0, Qn plus 1 is equal to 0. So in this case, you check what is the input you got, T value, that is 0. So you put 0 here. Now, do the same thing for the next case. You have the combination of 0, 1. Now see where is 0, 1. This is the 0, 1 combination. Qn equal to 0, Qn plus 1 equal to 1. So in that case, what is the value of T? That is 1. So write down 1 here. Now follow the same thing for the next case. 1, 0. Where you got 1, 0? This combination Qn equal to 0, Qn plus 1. Sorry, Qn equal to 1, Qn plus 1 equal to 0. So in this combination, what was the input? Input was 1, 1. So you go to 1. Okay. Now this 1, 1 combination check. This is the this is 1. This is 1. 1, 1 combination. In that case, the input was 0. So you can write 0. So this is the way to make the excitation table. Okay. Thank you.